Hello. So can you hear me?
Yes.
Yes.
Okay. Can you see the whiteboard also?
Yes.
Okay. Okay, wait a minute. Yeah. So today we will start the LU decomposition topic. Okay. LU decomposition. Which means that if we will have a matrix A, it can be a triangular it can be a rectangular matrix as well. So it does not have to be a square matrix. It can be a non-square matrix as well. So this matrix can be converted into two matrices as its factors. So L and U. So where L will be the lower triangular matrix with all elements on diagonal as 1, and U will be the upper triangular matrix, which will have on diagonal. It's not necessary to have ones on the diagonal. So this LU decomposition is useful for solving the equations. Okay, so first I illustrate how a matrix can be converted into lower and upper triangular matrix, starting with the simple 2 by 2 matrix. Okay, so for example, if we have a matrix as 2 minus 1 and 8 minus 1. So we want to convert it into LU, two matrices, L and U, and then when those L and U will be multiplied, we will get matrix A. So for this, we need to adopt an algorithm, and that algorithm will consist of, the first step will be that. So we will write an L matrix. So in this case, the L matrix will be of this form. Okay, so L matrix will be of this form. So there will be 1 on the diagonal and 0 here, and then there will be a term over here. Okay, so since it will be a 2 by 2 matrix. So the algorithm says that the first column of the L will be obtained by dividing the pivot number. Okay. Of the first row. So for example, in this case, first column we will obtain by dividing each element of this column by this number 2. So in this case, 2 will be divided by 2, so it will become 1. 8 will be divided by 2, it will become 4. Okay, so in the lower triangular matrix, we already know that the other element will be 0 over here, and then the first element will be, and then this element will be 1. So this will be the lower triangular matrix for this composition. But how we will get U? So U we will get by the row operations applied on this matrix. So in this case, the U we will get by the row operation. So for the row operations, we will try to make it into the echelon form. So for what row operation we will apply over here? So in this case, if we want to make this 8 as 0, so we will multiply the first row by -4, and then add to the second row, and then we will get the second row. So it will be now 2 minus 1 as it is, and then this will become 0 by this row operation. So -4 times 1 is +4, +4 minus 1 is 3. So in this case, we will get this as a upper triangular matrix. Okay, so now we will get L, and now we have already got L and U. Okay, so this means that our LU decomposition for this matrix has been completed. So we can verify it as well. Okay, just to make sure if it works or not. So I take L and then this matrix 1 0 4 1, and then U as this matrix 2 minus 1 0 3, and then we multiply it. So if we multiply it, so 1 times 2 is 2, 0 times 0 is 0. Okay, 1 times minus 1 is minus 1, 0 times 3 is 0, 4 times 2 is 8, 1 times 0 is 0, 4 times minus 1 is minus 4, 4 times 3 is plus, 1 times 3 is, so 4 times minus 1 is minus 4, 1 times 3 is plus 3. So it will be 2 minus 1, 8 and minus 1. So it was the original 2 minus 8, 8 minus 1. So that means our process for decomposing this 2 by 2 matrix into L and U component is correct. So in this case, we can see that this L is a lower triangular matrix with all diagonal elements are 1. And U is an upper triangular matrix with not necessarily the diagonal elements to be equal to 1. Okay, so this is the algorithm for this is the method for decomposing a 2 by 2 matrix. So the same algorithm we can use for for a 3 by 3 matrix. Okay, so that will give you some more details. So if 3 by 3 matrix is like this: 2 minus 1 0 4 1 1 and minus 2 4 minus 1. Okay, 2 minus 1 0 4 1 1 minus 2 4 minus 1. Okay, if this is the matrix, and then we want its LU decomposition. So for the lower triangular matrix, so it will be a 3 by 3 matrix. It will be of the form of 3 by 3. So it will be 1 0 0, and then there will be an element over here, there will be an element over here, 1 here, 0 here, and then there will be an element here and 1 right here. So we will need to find these 3 elements for the lower triangular matrix. So the elements on the first row, of course, it will be, you will start from 1. So 2, we will divide it by, we will divide this element of this first column by this pivot position number. Okay, so 2 is this number. So 2 divided by 2 is 2. 4 divided by 2 is 4. Minus 2 divided by 2 is minus 1. So we have got the first columns numbers. And the others, we already know that these are 0, 1, and 0. And then we need to find the number here. And 1, it will be a 1 over here. So we just need to find one more number for this lower triangular matrix over here. So now we move to for the upper one, upper triangular matrix U. So for this, we need to perform the row operations to make these two numbers 4 and 2 as 0. So, and then first row will remain the same, 2 minus 1 0, and then this will be now, okay, so for example, if we multiply it by 2, so it will be the row operation will be minus 2, so it will be minus 4 plus 2 and then 0. Okay, 4 2 minus 4, 4 2 and 0. So now we can then say that 4 minus 4 is 0, 1 plus 2 is 3, 1 plus 0 is 1. Okay, and now for this one, the row operation will be, so for the first one, the row operation was minus 2r1 plus r2, that is the new row 2. And for the second one, the row operation will be minus, it will be row r1 plus r3, that will be the r3. Okay, r1 plus r3, because minus 2 plus 2, that will be 0. Okay, so 4 minus 1 is 3. 4 minus 1 is 3. Minus 1 plus 0 is minus 1. Okay. So it will be minus 1. It will be minus 1. Okay. So now if we want to get this number over here, so now we will move our focus now to the second column. Okay. So in this case, we move our focus into the second column and the second row over here. So here we will have 3. So 3 will become the pivot number over here. So this will be divided by, this number 3 will be divided by 3. So this will be 1, it's already there. But this 3 will be then divided by this pivot number 3 divided by 3, that will be 1 over here. Okay, that will be 1 over. So in this case, we will complete the L, but we need to complete this U by the row operation. So for this row operation, this 3 should be 0. So we will apply another row operation. So that will be minus R2 plus R3. That will be the R3. So in this case, 2 minus 1, 0, 0, 3, 1, and then that will be 0. And then 3 minus 3 is 0. And then minus 1 minus 1 is minus 2. So that's it. So in this case, we have got, this will be our U matrix, and this will be the L matrix. So this matrix has been converted into lower and upper triangularized matrices.
Can you please repeat how did you complete the lower triangular matrix?
So for the lower triangular matrix, we already know that 1 is on the diagonal. So over here, and then all others over here will be 0. So only these 3 positions we need to find. So these first 2 positions we found by from the first column. Okay, from this first column over here. So here we have 2. So we divided 4 by 2, and then we divided minus 2 by 2. So we got 2 and minus 1 over here. Okay, and then the this element we got from here when we already applied the row operation to U, and then from this 3, then we got it like 1 over here.
Okay, gotcha.
Yeah. Okay, so the application for this LU is in the solution of the equations, system of equations. Although you can see that, yeah, in this case, the advantage for the solution of the system of linear equations is that the number of computations required becomes less, okay, compared with some other methods such as finding the inverse of the matrix. So that's why computationally this method is efficient. Okay, so for the application of this method, let's say that we have the system of linear equations, something like this. Minus, maybe I can do it on the next slide. Okay, so application of LU method for solution of system of linear equations. Okay, suppose we have the equations something like this. Minus 7x1 plus 2x2 plus 2x3 is equal to 3, and 21 x1 minus 5 x2 minus 3 x3 is equal to minus 1, and minus 14 x1 plus 5 x2 plus 12 x3 is equal to 4. Okay, so this system of equation can be written in this form: ax is equal to b. So where a is this 3 by 3 matrix, minus 7, 2, 2, 21, minus 5, minus 3, and minus 14, 5, and 12. I mean this is the matrix for the coefficients of these x1, x2, and x3. Minus 7, 2, 2, 21, minus 5, minus 3, minus 14, 5, and 12. Okay, and where x um, is the vector x1, x2, x3. Okay, and where b is the vector 3, minus 1, and 4. 3, minus 1, and 4. Okay, so the algorithm for solving this system is that we first solve, if for example, if we say that if we can decompose A into L and U, okay, then we know L and we also know U. So then because L will be the lower triangular matrix, so uh, we will solve first Ly by Ly times B, Ly times B. So where Y will be an intermediate vector, Y1, Y2, Y3. So this solution will be easy because we will just have to apply the forward substitutions. Well, uh, okay, because L will be a lower triangular matrix. And then we will solve another equation, Ux is equal to Y. Ux is equal to Y by the back substitution. Ux is because Y will be known from the previous case. So the unknowns x1 and x2 and x3 can be found from these equations. Okay, so therefore, our job now first is to decompose this matrix A into L and U components. So for this, we can apply the algorithm: minus 7, 2, and 2, 21, minus 5, and minus 3, and then minus 14, 5, and 12. Okay, so
Sorry, can you repeat why you written like Ly equals B and Ux equals Y?
it is why I have written it, because in this case, uh, as I have said, that y is an intermediate variable vector. Okay, so it is easier to compute Ly is equal to B. Okay, in this case, and from here, if we will find the y, and then we can find Ux is equal to Y. So it will then convert it into its solution X. Okay, so first, we have to go step by step. Okay, first we have to find y, and then we have to find x in this method. And as the method says that this will greatly reduce the number of computations needed. Of course, there is a proof for the decomposition of this method into this, which explains that why we need to find L and B. But I'm not going into that proof over here. Okay, so in this method to apply, first we will find the L and U. Okay, so for finding L, then what I will do is I will take this first column, okay, and then divide it by -7, which is the pivot position. So it will be 1, then -3, and then it will be 2. Okay, 1, -3, and 2. And the other positions, other elements are 0, 1, 0. I can right away write it. And then for u, uh, as a first step, then we have to make 0 these 21 and -4. So it will be -7, 2, and 2. And to make it 0, so it will be, what I will need to do is I will take 3 times row 1 plus row 2. That will be row 2. Okay. So it will be 0. Then 6 minus 5 is 1. And then it will be 6 plus -3 is 3. And for this, what will be the row operation? So it will be -2 row 1 plus R3, and that will be R3. Okay. So -2 means, if for example, it will be plus 14, then it will be -4, -4. Okay. So now 14 minus 14 is 0. And then it will be 5 minus 4 is 1. And then 12 minus 4 is 8. Okay. So now we get this, but this is not the final form of the upper triangular matrix. The final form, for the final form, we need to do one more row operation. Okay, so from here, we can now move our focus to second column and the second row. So here, this one is the pivot position over here. So this pivot position, we will divide this one by this pivot position, pivot number 1. So 1 divided by 1 is, of course, 1. So that will be the last element which we will need for lower triangular matrix. So lower triangular matrix is completed: 1, 0, 0, -3, 1, 0, 2, 1, 1. And to complete the upper triangular matrix, so we need to do one more row operation. So it will be -7, 2, 2, 0, 1, 3. So I need to make this one as 0. So it means what I will do is I will apply a row operation that will be minus row 2 plus row 3, that will be row 3. So 1 minus 1 is 0, 8 minus 3 is 5. So this will be the upper triangular matrix. Okay. So upper triangular matrix is this, and lower triangular matrix is this, and then we can verify it as well. I will not do verification over here, but you can do by yourself. L times U, that will be equal to this A. So now we will apply this for solving this. Now we will solve for Y first. Okay. So it will be Ly is equal to B. So it will be L means this one. So y1 is equal to b. B is 3. Okay. And then minus 3y1 plus y2 is equal to -1. And then from this lower triangular matrix. Okay. So 2y1 plus y2 plus y3 will be equal to 4. So this this system is easy to solve. So y1 we already know is 3 now. If we put the value of y1 in over here in the forward substitution, so -3 into 3 plus y2, so we will get -1. So from here we will get y2 is equal to 9 minus 1 is 8. Okay, we will get y2 is equal to 8, and then 2 from the third equation, 2 into 3 plus 8 plus y3 is equal to 4. So from here, y3 will be equal to 6 plus 8, 14, minus 14 plus 4, that is equal to -10. So y1, so the vector y1, so vector y will be 3 minus 3, 8, and minus 10. Okay, 3, 8, and minus 10. Okay, but of course this is not our answer. Our answer should be x1, x2, x3. So for x1, x2, x3, we will apply this equation. So ux is equal to y. So what is u? U was this. So minus 7x1 plus 2x2 plus 2x3 is equal to y. So y was 3. That is equal to 3. And then x2 plus 3x3 is equal to 8. And then the last one is minus 10x3 is equal to no, so yeah, here it's not minus 10x3 because we are applying the U matrix. So x1 plus 3x3 is equal to 8, and then this one is 5x3. 5x3 is equal to minus 10. So from here we can find like x3 is equal to minus 2. X3 is equal to minus 2, and then x2 plus 3 into minus 2 is equal to 8. So from here we find x2 is equal to 14. And then from here, the first equation minus 7x1 plus 2 into 14 plus 2 into minus 2 is equal to 3. So from here we find x1 that is equal to 28 minus 4 is 24. Minus 24 plus 3 is minus 21. Is minus 21, right? It is minus 7x2 x1 plus 2x2 plus 2x3. Just check it. I'm just checking it. Okay, minus 20. Okay, so yeah, so it is minus 7x1. So it is 14 times 2 is 28. 28 minus 4 is 24. 24, and then minus 24 plus 3 is minus 21, and then minus divided by minus 7. So it is equal to 3. Okay, so x1, the value of x1 will be equal to 3. Okay, so just check it, just verify the solution. Okay, so minus 7 into 3 plus 2 into 14 plus 2 into minus 2. 2 into minus 2. X2 is equal to, so the value of x is equal to minus 2. So what is the, what do we get? Minus 21 plus 28, that is equal to plus 7 minus 4 is equal to 3. So it's correct. So similarly, the other answers will be also correct. If I have not made any mistake in the calculation, so it should be correct. The answer should be correct. So 3. So the solution is, so the final solution is then x is equal to, starting from the top, 3, 14, and minus 2. Okay, this is the final solution. Is it clear?
Can you repeat how to find unknown component of L?
These unknown components of L?
No. Third, which we found from U.
From U, from here?
Not previous U. We divided one by one.
Yeah. So this one has come as this one divided by 1.
Okay.
Divided by 1. So, and this minus 3 has come from here. So 21 divided by minus 7. Okay, and this minus 14 come has minus 14 divided by minus 7, that is 2. Okay. So this LU decomposition is not just for the square matrices. This LU decomposition can also be found for non-square matrices as well. Okay. So LU decomposition of non-square matrix. You can also see this the example of the book as well. But let me, yeah, I can solve it over here. So for example, if I have something like this, a matrix, if I have a 3 by 5 matrix, so for example, so if I have this 4 minus 3 minus 1, 5 and 2, and then minus 16, 12, 2, and minus 17 and minus 7, minus 17, minus 7, and then 8, 6, minus 12, 22, 10. Okay. So in the case of the square matrix, so for example, if you have a 3 by 3 square matrix, so we get L and U, which are both like 3 and 3, 3 by 3. Okay. In this case, this is a 3 by 5 matrix. Okay. So its LU decomposition will be something like this. L will be 3 by 3 in this case, whereas U will be 3 by 5. Okay, U will be 3 by 5. So that we will get a 3 by 5 matrix in this case. So the process is same. There is no difference actually. So we start from the 4, okay, let me see if I write 4 minus 16, 8, 3 minus 3, 12, 6, minus 1, 2, minus 12, 5 minus 17, 22, 10, 2 minus 7, 10. So if we want to find its lower triangular matrix, so it will be a 3 by 3 matrix, as I have just explained. So it will be 1, 0, 0, and then 1 here, and 0 here, and then 1 here, and then we need to find these values. So what are these two values?
It's minus 4.
Yeah, minus 4, because minus 16 divided by 4 is minus 4.
And 2.
And 2. Okay, and 2 over here. So only need to find over here this value, but of course we need to find a U as well. So for U, what we will do, we will apply a row operation. Okay, so what will be that row operation? So maybe I can write it in different number. So that row operation will be that we will multiply this first row by 4 and then add to the second row. So it will be 16, then it will be minus 12, and then it will be what? Minus 4, and it will be 20, and then it will be 8. Okay. So Now we get 4 minus 3 minus 1, 5 and 2, same as this first row. The second row will now change. So 16 minus 16, that will be 0. And then 12 minus 12, that will be also 0. 2 minus 4 will be minus 2. And then minus 17 plus 20 is 3. And 8 minus 7 is 1. Okay, so this row operation, okay, so maybe I can erase this. So for the second row operation, I put these rough values. So for this, what row operation I need to multiply this first row by minus 2. So it will be minus 8, 6, 2, minus 10, and then minus 4. Okay, it will be minus, no, it will be minus, yeah. So because I am multiplying it by 2, right? So it will be minus 8, 6, 2, minus 10, and then it should be minus 4. Minus 4. Okay, and now I'm going to add it. So 8 minus 8 is 0. 6 plus 6 is 12. Minus 12 plus 2 is minus 10. And 22 minus 10 is 12. And 10 minus 4 is 6. 10 minus 4 is 6. Okay, so in this case, now our focus will be on the second row over here. But in this case, in the second column, there is and in the second row, there is no pivot position over here. Okay, because 0 is not a pivot position. So therefore, we will move to the next column. So in this case, we will skip this column because this column has no pivot position. That pivot position is the one which is non-zero number. So the first non-zero number is in the third column. So in this case, we will need to skip this column. Okay, so we will have to skip it and we will move to the second, the next one. So now in this case, we have this pivot position as number 2, minus 2. So this minus 2 will be then will be the one that will be the divisor of minus 10. So minus 10 divided by minus 2, it will become 5 over here. So minus 2 divided by minus 2 is that will be 5. Okay, and then we will apply the row operation over here. So now we will get 4 minus 3 minus 1, 5 and 2, and then it will be 0, 0, minus 2, 3 and 1. So for this row operation, that what I have to do is I have to multiply this second row by 5. So 5 times the row 2 and then add to the row 3. So that will be the new row 3. So anyway, this will be 0, this will be 12. This was 12. This 12 come from where? Okay, minus, okay, 6, okay, this was 12, okay. So this is, yeah, this is 12 and then I think I had made some mistake somewhere. Because this should be, this should not be 12 over here. This should be 0 because otherwise we will not get the upper triangular matrix over here. So where did I make the mistake? So first I had this matrix 4 minus 3 minus 1 5 2 minus 16 12 2 minus 17 minus 7 and then 8 minus 6 minus 12 22 and 10. Actually in my original plan it was minus 6 over here. It was minus 6 over here in my original.
Switch the rows while finding U.
Hmm?
We cannot switch, yes, rows, like row number 2 and 3.
Yes, for finding the LU decomposition, there is a restriction that we cannot switch the rows. So switching of the rows is not allowed in the LU decomposition. So therefore we cannot switch the rows. Yeah, actually, it doesn't matter if it has to be +1 or -6, but I don't want to make more mistakes. So therefore, originally I had over here -6, so I will stick it with -6 over here. So it will be 0. Okay, it will be 0 here. Okay, it will be 0 here. Yeah, actually, we skipped it not because the 0 was here. We skipped it because both of these values were 0 over here. Okay, so that's why we skipped it, and then we found 5 over here, and now we have and -2 12, and then over here is 6, and then it was 0. It is 0 over here. So for the row, so 5 times R2, so it will be 10 minus 10, that will be 0. And then 15 plus 12, that will,
I'm sorry, shouldn't it be -5?
Yes.
it should be -5. Yes, yeah, that's what I was wondering. It should be -5. Yeah, -5. Okay. It's very easy to make mistake in these calculations, so that's why it's better to write those rough calculations over here. So minus R, it will be 0, 0, and then it will be +10 and -15, and then -5. Okay. So now, yeah, so so now I will take 0 plus 0 is 0, 0 plus 0 is 0, -10 plus 10 is 0, and then -15 plus 12 is -3. And then -6 plus 5 is 1 over here. So therefore, this will be the lower triangular matrix, and the upper triangular matrix will be this one: 4 minus 3 minus 1 5 2 0 0 minus 2 3 1. And in this case, if you see that and this is the diagonal. Okay, this is the diagonal. So all the elements under the diagonal should be 0. So that means this is the upper triangular matrix. Okay, that it is the upper triangular matrix, and this is the lower triangular matrix. So we have decomposed this matrix into lower and upper triangular matrices. Okay. So similarly, in this book, there is another example for for something like 3 by 5 matrix. Okay, 3 by 5 matrix. That means something like this. Sorry, 5 by 3 matrix. Longer shape matrix. So you can also have a look at how they have decomposed it into lower and upper triangular matrices. The process is the same. Okay, the process is the same. There is no difference. Okay, so this was about the lower and upper triangular decompositions. There is another variation for the LU decomposition that is called as the LDU decomposition. LDU decomposition. So what is the LDU decomposition? In the LDU decomposition, L is the lower triangular matrix with all elements on the diagonal as 1, where D is the diagonal matrix. Okay? D is a diagonal matrix with only the non-zero elements on the diagonal. Okay, will only the no, and where U is a modified upper triangular matrix. It's a modified upper triangular matrix, where all the elements on the diagonal of U are also 1, because in the original form, the elements of U on the diagonal were not ones. Okay, they were different from 1. So let's see it. See the example for the illustration. So for example, if we have a matrix B, 2, -1, 0, and 4, 1, 1, and then -2, 4, 1. Yeah, I will take just a few more minutes, so then I think it will be finished. So this is the same matrix as we did before in this first one. Yeah, this is the same matrix: 2, -1, 0, 4, 1, 1, -2, 4, -1. And we already have decomposed it into lower and upper triangular matrices. So I will just write it over here. So its lower triangular matrix, as we did before, was this. Its lower triangular matrix was this. 1, 0, 0, 2, 1, 0, and -1, 1, 1. And its old U was, that means previously the U which we found was this. It was 2, -1, 0. Its U was, yeah, let me find it. Yeah, its upper triangular matrix was this. Okay, its old upper triangular matrix was this: 2, -1, 0, 0, 3, 1, and then 0, 0, -2. So that was its old upper triangular matrix. So for example, if you take L and then multiply by U, you will get this P. But from this, in this LDU decomposition, L will remain the same. New and old, they will remain the same. We will introduce one element D, which will be only the diagonal matrix. And that element D will be the one that will be obtained by dividing each row of this U by its pivot position. So for the first row, the pivot number is 2. So we will divide it by 1. Okay. So, sorry, that will be the new okay, let me we will introduce a diagonal matrix. Okay, so that diagonal matrix will be the one which will be having 0, 0 on the elements, non-diagonal elements, and its diagonal elements will be these three: 2, 3, and minus 2. 2, 3, and minus 2. So the same diagonal elements as were in the old U. And in the new upper triangular matrix, that we will get by dividing first row by this 2. So it will be 1, then minus 1 by 2, and then 0. The second row by 3, so it will be 0, 1, and then 1 by 3. And then the third row will be by minus 2. So it will be 0, 0, and then 1. Okay. So in this way, you will get this LDU decomposition. So it means that if you want to decompose a matrix into LDU, so first you will decompose into L and U, and from this U you will get those new D and U matrices. Okay, is it clear?
So to find the D, we just take the diagonal of all the U, yes?
Yes, to find D, we will just take the diagonal elements of old U. And the old U will convert into new U by dividing each element of U by their respective pivot elements in each row.
So what's our next step? What we will do with these three?
With this LDU decomposition, the next step.
Yes.
Yeah, this can be also used for the application of the system of the linear equations. So nothing special.
So original B matrices is a multiplication of all of these parts?
Yes, original B matrix will be then the multiplication of L, D, and U. B will be equal to L, D, and U. So you can multiply a D by U and then multiply that L by D by U. So this is this. Okay. Any questions?
May I ask about the previous exercise?
Which one? This one?
About non-square matrix.
Yeah, this one, the one I'm showing you.
So what was the purpose of eliminating minus 10 in U?
We eliminate minus 10 to obtain the U matrix. Okay. So the elimination of U will give us the U matrix.
So instead of minus 10, there always must be 0?
So yes, instead of, yes. So all the elements under the diagonal should be 0 in the upper matrix. Okay, so that's why we make zeros under the pivot position.
Okay, thank you.
Yep. Okay, that's all for today. So from the next Friday, we will start with the new topic, probably determinants. Okay.
Okay, thank you. Goodbye.
Thank you. Bye.
Thank you. Goodbye.
Okay, bye-bye.